All right, so this is problem 1 from the AP Calculus 2022 free response section. Now this is a calculator question, so I'm going to have my calculator up and running in case I need it. Now what they give us here is they give us this function right here, and that is a rate. And so we better put that in a box because that's important. The rate at which vehicles arrive is given by that function. Now it says, write but do not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza. Oops. So what we want to do is we want to write down how do we take this rate and come up with an amount. So the total number of vehicles that arrive, well, now important thing to notice is that it says that arrive at the toll plaza, not that how many there are. Now, they actually tell us there are no vehicles waiting in line in the beginning. So that means our integral is going to be from time 1 to time 5 of a of t dt. Now, if you're the type of person that needs to, and I don't think the AP test requires it, but you could write the actual function inside here. So we have square root of sine of 0.62t underneath the radical dt. Now it says write, but do not evaluate. So we can just leave it at that and call it good. For part B, it says find the average value of the rate. So key thing, we want the average value of what? Of the rate. So we want the average value of this function right here. So we want the average value of a of t from t equals 1 to t equals 5. So using the definition of average value, it's going to be 1 over 5 minus 1, the integral of 1 to 5, a of t dt. All right. So here we're going to actually have to find the value. So this is where we're going to use our calculator. So I'm going to store this function 450 square root sine 0.62x. And then I'm going to go down to integral. And so we're going to go 1 to 5. And I'm just going to type in vars function y1. Now that's according to x. So we have that. And then, so that is 1502.17147 86 ... and then we have to divide that by 4. So we get 375.53, and we always round to 3 places. So 375.537. Now it's an average value of a rate, so we have to remember that this is a unit. So cars per hour. And actually, I think that's incorrect because it actually made a mistake here. It says vehicles. So it's possible, had I written that, I would have gotten that wrong. But let's change it right here. Vehicles per hour. There we go. Part C. Here it says, is the rate at which the vehicles arrive increasing or decreasing? So it's asking, is the rate, is a of t increasing or decreasing at t equals 1? That's the question. So a related question is a prime of t positive or negative at t equals 1. All right. Now we still have a of t stored in our calculator. So let's go down to 8. So we're going to type in our function, and we're going to type in a value of 1. So what we have is a prime of 1 equals 148.947. Now the key thing is that it is greater than 0. That's the important part. So a prime of 1 is greater than 0. Therefore, a of t is increasing at t equals 1. And then finally, part D, it says a line forms whenever a of t is greater than or equal to 400. Number of vehicles in line for a of t is given by this integral. From a to t, a of x minus 400. Now they tell us that a is the time when a line first begins to form. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza. Now it says a line forms whenever a of t is greater than or equal to 400. So we have to use the graph to figure out when this happens. So that means since we have this, I'm going to go to my window, and we've defined this interval from 1 to 5. And so I'm going to go down to zoom fit. Okay. And I'm going to graph y equals 400. So in this region up in here, this is where a line is forming, because anytime the rate is greater than 400, we have a line. The cars are arriving faster than they can process them. So we have to find when it starts to form right here, and then when it ends right there. Okay. So I'm going to use my intersect command. So left bound, press enter. Right bound, press enter. And the intersection is at x equals 1.4921. So that's A in this problem, 1.45291. All right. Now it says, find the greatest number of vehicles in line at the toll plaza in this time interval. So what it's saying is, find the absolute max for n of t on the interval a, 4. All right. So since we have an absolute maximum, what we have to do is we have to calculate what is the value at these 2 points, but we also have to find what are any critical points for n of t. All right, so let's put, t, n of t, I'll just do it sideways. So at time a, so if I plug in a in for t right here, well, that's going to be 0. Now what about if I plugged in 4 in for t? All right. Now since we already have a of t saved in y1, I can just go ahead and calculate this integral from 1.45291 to 4. And then we've got y1 minus 400. And then we have 63.325. Now, are there any critical points for this integral function? So what is n prime of t? Well, that's going to be a of t minus 400. Now essentially what we're asking for is what is the difference and when is that difference 0? Well, that difference is 0 here at A, which we found, but also over here. So I'm going to find that intersection. And we get, let's call it B, 3.88013. So we'll call that B. So now instead of 4, whoops, I'll call that back. All right, deleted that, so I'll just type it in again. 1.45291 for my lower limit, and then for my upper limit, 3.88013. Oops. y1 minus 400 dx. And we get 67.0186. So 0.19. So at this time, right here, at 3.8013, we've justified that this is the absolute maximum for this function. So that is the greatest number of vehicles in line at the toll plaza for that interval. Thanks for watching. If this helped, give it a like and check out the other videos for the AP Calculus 2022 free response.